off talking about what is it and why we're doing it. Why is it so important? This year is a tough year. Moisture and honey, they go together and they don't go together. So what are we doing? Brad's gonna talk about extracting honey, and my phone is just blowing up with people asking me, when do I extract? When do I extract? And I keep telling them when it's ready, right? When it's ready. And of course the question is, well, when is it ready? So who would attempt to explain to me really short the difference between honey and nectar? Water content. That's exactly it. So in the flower, the nectar has a high water content and a low sugar content. Now we talk about high sugar content plants, but we're talking about plants that have 0.75% sugar and 99.3% water, right? So what do the bees have to do with all that water? Got to dehydrate it, flap their wings, move the air around, dehydrate it. So I typically use a discussion about your towel in the summer, and you've been out in the pool and you get out and you dry off with a towel and you wad it up and drop it on the floor right there in the hallway. How fast is that towel going to dry out? It's not, because it's all packed together. So what do we do with our towels? We take them, pop them out, and we lay them across the chairs, right? Why are we doing that?
Surface area.
Surface area. We're increasing the surface area so it can dehydrate. Guess what the bees do when they bring the nectar in? They scatter it in all of the supers, all the open holes they can find. They scatter it out, and they're pushing air through the hive so they can evaporate the moisture off. And as it gets thicker, they then begin to condense it down into fewer cells. So they are dehydrating it. So what's the target? 18, 18.3, 18.4. Go ahead. Do I have a slide clicker, or are you going to do it for me? There we go. All right. So our target is 18.3, 18.4. The question is, where did that number come from? Humans. Humans doing the best we can to figure out what the bugs are doing. Nectar has different properties. The nectar from some flowers will crystallize faster than others. Some will ferment faster than others. So it's nectar based. The bees know the difference. We don't. The bees compartmentalize that honey in all those little cells, and you'll notice that sometimes some of it's capped and some of it's not. Why? It's not ready. So what they've capped, they've determined is not going to ferment. But they also understand the source of the nectar. Now, it's not always safe for us just to say, the bees capped it, so it's good, I can extract it. I absolutely have uncapped frames and extracted it and measured 19. Above our standard number. But again, our number is for us as humans to have something. The bees keep it compartmentalized in all the little cells. They're not mixing it all together. We do. Once we cut the capping off and we do the extraction, it's in a bucket. You mix it around and you have to measure that, and that is your moisture content. So the question is, what does that look like? So this is a real common tool. There are others. This is the cheap end of the market. And when I say the cheap end, I absolutely mean the cheap end. In many cases, you buy 5, find 4 that don't work and send those back and keep the one that does. Everything from focus issues to blurry screens to literally I've had the eyepiece fall off of them. These are not high-end tools at all. They also come with different measurements. So you see there's a scale in there, and you've got the white above and the white below and the blue above. There are often 2, if not 3 scales on that screen. I try to find the ones with 2. We're interested in the BRIX, B-R-I-X, and in the moisture content. Refractometers are made for lots of applications. There's refractometers for honey. There are refractometers for making wine. There are refractometers for measuring the antifreeze content in Honda cars. Right? So you got to make sure you get the right one so it has the right scale. The next most important thing is it has to be calibrated. So go back to the very first picture, and you'll notice right on the top, there's that little black dot right above where it says ATC. It's right here. There's a little bitty screw inside of that, and we have to calibrate these units. That ATC is supposed to mean automatic temperature control. Where did I tell you this was made? It is not. It does not automatically adjust anything. It is really rudimentary and basic. So we use extra virgin olive oil just from Walmart. It needs to be the extra. The thing about this is it's very common. You can buy actual calibration fluids. So they'll send you a calibration fluid. A calibration fluid is any fluid with a known moisture content at a specific temperature, right? So you could use this calibration fluid and you can calibrate your refractometer. So now you know it's accurate. This fluid, if I could read that small print, has a 65% plus or minus 0.1, so pretty accurate, at 70 degrees. So you would get your refractometer at 70 degrees, you would get your calibration fluid at 70 degrees, and then you would calibrate it. And it's good for 70 degrees. So what happens when you go outside and what's the temperature today? So that's where my experiment came in. Most of us use extra virgin olive oil because it's very stable and it has a wide range of temperatures for which its Brix reading is the same. Its Brix reading value is 71.5. It's 71.5 at 70 degrees, it's 71.5 at 95 degrees. It has a wide range, it's very consistent. So it makes it great to just use a very common item to calibrate your refractometer. So how do we calibrate it? You simply take the oil and put it on the screen here. You just need a film that covers all the way. You flip it over, mash it. You don't want any air bubbles. And then you look through the eyepiece and you adjust the screw until the Brix reading is at 71.5. So I tried to blow this up as big as I could for you and then show you the difference between 71.5 at the bottom also equals about a 27.5% moisture content. But that's just for calibration with the Brix. Once it's calibrated at that temperature, you can now measure your honey. It all depends on everything being equal at the same temperature. You can't take 90-degree honey, stick it on your refractometer that you calibrated at 70 degrees inside your house and immediately take a reading. You've got to wait till it all comes to the same temperature. You need to give it 4 or 5 minutes to stabilize. Once you have calibrated with the Brix side, then we're looking at the water percent. And so this particular example is measuring 15.8. That's a pretty thick substance. This is not my picture, it's just a Google picture right quick so I can show you how it works. That's a pretty thick honey. That's usually thicker than anything I've seen. I have extracted at 16 and a half, but I don't think I've extracted anything out of the hive that was less than 16. You can dehydrate at your house, which is the big conversations on Facebook right now. People got anxious and they started extracting and they didn't measure, and then they realized they were significantly above, what was the number, Jay? 18.4, 18.2, somewhere in there. And so they were significantly above that. And then that becomes worrisome because what can happen? You get a 5-gallon bucket that begins to ferment, you can't stop it. You're going to lose the whole bucket at that point. Some people will fight and try to make mead out of it if you're into making mead, but there goes a 5-gallon bucket of honey that disappeared real quick simply because you didn't spend $25 on this little cheap tool. All right, so we've calibrated it, and now we know what we're looking for. So how important is the calibration temperature-wise? So I did some experiments, and I hope the numbers will mean something to you. So in my garage, I was running 2 dehumidifiers because it was raining like fire, had been for several days. I had a couple of hives that I wanted to go ahead and treat, but I had to get the supers off in order to treat. So I did pull, and I treated those colonies, and I brought the honey back to the house. So the garage was 26%, 98 degrees in the garage. The dehumidifiers kick off a fair amount of heat in addition to just outside temperature, right? So we know it's very warm, and we know it's a low percent. Relative humidity is such that it should take the water moisture out of the honey. Did anybody else see that amazing post that Bob Cashwer shared? Wow, okay, y'all need to go to Neoba Hive he posted a long article that explains relative humidity fantastic. And there's a chart in there that shows the equilibrium between relative humidity and honey. At 60% relative humidity, honey will stabilize at 18%. It's an amazing, perfect number. But what does that mean when we've got 91% humidity? Honey is high.
You're going to be absorbing.
Exactly. Honey is high groscopy, GRO. It absorbs. So when we're at 91% in the morning and you have supers with uncapped honey, that honey is taking on moisture. When we're below 60, honey is giving up that moisture. So in the garage at 26% running fans, I'm pulling moisture out of my honey, trying to get it down to the 18% before I fully extract it and put it in the bucket before it gets dangerous, right? All right, so here was my reading. So I took it at 98 and I calibrated at 71.5. Okay, so it was calibrated for 98 degrees in the garage. Now this was an experiment. This wasn't about testing honey. This was about the capability of the little tool. So then later that evening, when the temperature in the garage had cooled off to 88 degrees, I just simply looked at it. I never removed the oil from the refractometer. I left it on there. Same oil, sitting in the garage on the table, same environment, nothing else happened. It measured 72. So in those 10 degrees, I was already off by 1/2 of a Brix point. How much is 1/2 of a Brix point? Later that night, I took it in the house. The house was 73. It measured 73.2. So in a 25 degree difference, it was 1.7% moisture points off. Well, that's 2 points. If you're trying to hit 18%, you're 2 points off because your calibration's off. You don't know where you are. Right? So if I just do the 10 degrees, that was 1/2 of a Brix points. Brendan, go back to the picture where it was zoomed in real big. There we go. So if we take 1/2 of a Brix point, I'm trying to look for one that's easy to read. So if we're down there at 82, 70, 18. Yeah, so it's almost 1/2 a point, getting close to 3/4 of a moisture point when you're talking 1/2 of a Brix point. That's a big deal. So what did I learn? Calibrate the refractometer where I am. Calibrate it every time. Not just, hey, I calibrated, it was in the garage and I used it on Tuesday. Okay, well, no. The next time I use it, I've got to calibrate it again because the temperature in the garage has moved. The humidity in the garage has moved. How many times did I open and close the door in the garage? It doesn't take long. You open the door and boy, it just whooshes the air in and out, and all of a sudden I've contaminated the garage. And instead of 26%, I'm now at 45 or 55. Okay, so does that make sense about refractometers? How you calibrate them and why it's important to calibrate it before you use it.
When you took your sample, it was still on the frame. You had extracted it again, right?
I did both. For the ones I was worried about, yes, I tested them on the frames. Are you covering anything with the fans or?
I can throw that on the front.
So Brad's going to talk about if you've got the frames out and you measure and it's too high, what to do with it then. But I've also extracted it and it's been in the bucket. And then you've heard Mike talking about using a bucket to a bucket and dripping it and running a fan and painful experiment. I mean, it's really painful to deal with rotation of buckets. I'm from the South, we make up stuff. So I had some that was too wet. I dumped it back to the extractor. My extractor is this big, I had 8 gallons. I've got to get a full point out of 8 gallons. Surface area is important when you're trying to dehumidify, right? Okay, so I took 2 plastic spatulas and I zip tied them down my extractor and turned it on at the lowest setting so that it was stirring the honey and moving that surface because it'll only extract out of the top 1/2 inch of exposed surface area of the honey. So I was trying to stir that, left my extractor running all night and into the next morning to get it down to the 18. Painful. It's so much easier to let nature do it, and when it's ready, it's ready. Other questions?
We've got a couple of folks that make rock fragrances, honey, and refractometer.
Yes, sir. Where's it, olive oil? Okay, is there a problem if we leave that open out
So if you left the extra virgin olive oil open, could it contaminate it by the oil taking on or relieving moisture?
No.
Not being a chemist, but I don't think so, because that's why we use it. It's so stable at its temperature. For me, the little plastic thing was down, so the air wasn't going to get in and change my sample. But I don't think has the property that it's absorbing and releasing moisture, or else it wouldn't be a very good calibration.
It does not.
It does not. Okay, so someone else much more definitive than me.
You do want to make sure that you use fresh olive oil, because I found my container from last year in the shop that it's clear out.
What did it do? So Brad's talking about the importance of using new, fresh.
It went rancid.
It went rancid.
Yeah.
Oh, okay. Just had it out in the garage, subject to heat and cold. Okay.
How would you clean it if
So, the instructions say don't submerge it. I use just water and a paper towel, and I'm just cleaning that glass and on the back side. And once it's clean, I use a towel and dry it. At that point, I feel like it's clean enough. Is there any moisture content? I've been using just tap water. Yep.
If it's honey, you just lick it off and dry it with it.
Shh. All right, so I've got several up here. Lori said some people have brought some honey. You're wanting to test it at break time, so that's fine. So we'll run through and calibrate them, because all these have not been. They were calibrated, but not here in this room at this temperature, at this humidity. So we'll calibrate first.
you need a special screwdriver?
They typically will send you with this handy dandy little high quality screwdriver in the kit. They will also send you with these little things, which I believe are called pippets. We pretty much throw those in the garbage can. We don't use those, do we, Brad? Your screwdriver or your finger works just good. Smear it on there and eat the rest.
It's a
So,
pipette.
pipette, thank you. See, again, I'm not a chemist. There are some instructions, but they work about as good as any other foreign written instructions.
And if you don't have a refractometer?
You can buy fry refractometers. I keep some in stock, but honestly, you can pick them up from Amazon. It's just a risky business. Make sure you look for the ones that say free returns.
And I'm gonna put a plug in for Dane, because he won't do it. He has done the work of getting a bunch and sending the broken ones back, so you get one. I've got 2 out of 10 that I did myself. He's done my legwork for it.
If you want a much more expensive one, a much more accurate, I think I can't remember the ICENX. They're about 195, and then there's another digital one that's closer to 300. Those are high quality units. For what we're doing, this does work. Just calibrate it, pay attention.
And what would you estimate the margin of error to be? When we say 18.1, 18.2, 3, 18.4 win?
So remember the part I spoke about, he was asking about the margin of error on reading the moisture of the honey. Remember I spoke of the nectar can impact the speed at which it ferments. I have honey on my shelf that's over 5 years old that measures 19.5 and it has never fermented. And it's because of the nectar source. We can't tell the difference. The bees do, they understand and they know. So we have to make up a number that is like this very conservative, safe number. And that's where that 18.4 comes from. But if I had something that's 18.5, I'm going with it. It's good.
So I got mine all calibrated and I went back in the house and then I thought, I wonder what the honey on my shelf is looking like. And so, and I have various sources, but I took some from last year's crop and it was 18 on the nose. And, so, but.
Well, you can ask the question, how fast does it ferment? It might be months before it starts to ferment. It might be weeks. Has anybody had any ferment? I have. I've lost a whole 5-gallon bucket of stocks. Yeah, it's terrible. Somebody did call me a few weeks ago and they said, why is my honey beginning to develop bubbles? It was honey from last year. So from last year, it was just now starting to ferment. You know who that was?
Well, you were talking about the source of the nectar being the primary factor, and I agree, but an almost equal or more so factor is the yeast.
The natural yeast that are within the honey?
Well, the yeast is in the air, and honey can pick up yeast from all kinds of sources, and as long as it's open, it's going to. And so, we don't have the ability to test for the yeast directly in any way, but that's a major factor. And if your honey came having been exposed to a windstorm that carried a lot of yeast into the hive and so forth, it will definitely ferment faster than it otherwise would have.
Bob actually coached me through an experiment last year. I had a 5-gallon bucket that had 75 to 80% crystallized. So the question was, does that change the moisture content in the remaining liquid honey that's in the bucket if the crystals were pushing off moisture in order to crystallize? So we measured the moisture content of the liquid honey still in the jug, but I mean, it's like this big slurry, right? But we tested that, and then I have a cabinet that holds 95 degrees, and I put the bucket in there for a week, and it melted all the crystals back out. It only moved half a point. So it does move it, but it's not great volumes of moisture that's being pushed out of the crystals and into the liquid honey. That was a fun experiment. He pushed me to do that.
The only way I can see it being problematic, if you had a bucket that was not sealed well, and it was in a high humidity environment, that hygroscopic property you alluded to, that bucket could start to absorb moisture from this environment.
Yeah, I think so. If we're having high humidity, like these 90% mornings, you're going to take it on. But I think you identified it with uncovered, unprotected. I'm not sure people just leave buckets of honey uncovered sitting somewhere.
Yeah, I mean, if you had a bucket and most of the bucket was empty, so there was only a little bit in the bottom, the honey that's down below is not going to absorb moisture, nor does it give off moisture.
Okay, well, so, yes ma'am?
If the moisture is high, what would you do? Do you have methods to know?
He's going to cover that in his presentation after the break. And then if there's time left, we'll do a Q&A, and then we can add on anything that anybody else wants to offer, some other method of how they do it. We'll just tack that on to the end of this meeting. Is that what you got, Malcolm? You got an idea of how to handle that?
I was just gonna talk about, like how you have the moisture content, another way to do that in case anyone ever gets a bucket.
Well, let's do this. Brad's going to cover it in his, and then whatever he doesn't say, everybody else just offer, what have you done? Because I think it's a matter of just being creative at that point. So, okay.
Be careful on your frame. Sometimes you test one, and it might be where it's supposed to be, but a couple others may not be. And last year I had a box, and I pulled out the frames, and they had little bubbles coming out. It had fermented at the high, they never got it, so I just let the bees have it.
So that's a good point, though, is they can say test multiple frames, not just one frame, because they're not equal. Because even if the nectar is coming in now, my bees are still bringing in nectar, it's crazy. So there is capped honey in the hive, there is uncapped, and they're bringing in more wet moisture. So they're actually creating a higher humidity environment in the hive, trying to dehydrate the fresh nectar. So it's a complicated process.
The aggregate honey, moisture content of the hive is being upset by this nectar being brought in right now.
Okay, we are going to take a quick break,